I think we have enough people to get started. So we are live on YouTube as well. So this is so we do this meetup almost every month, once a month, and we've been doing this for over almost over 2 years now. And every month we get together and we talk about Kubernetes and related cognitive technologies. Uh, so Yes, so that brings us to today. If just before we start, I'd like to say that, as much as possible, stay on mute unless you have a question. And since we are already late, I'll go ahead and introduce our first speaker for today, and we can get started. So the first speaker for today is Karthikeyan Govindraj. So he works for BlackRock, which is one of the biggest investment management firms, I believe. Yes, and he works with a lot of cloud native technologies. Also contributes to some Kubernetes community projects. He's also codes mostly in Go and writes developer tools and likes making developer experience better. So I think that's a short introduction of him, and I'm sure he will introduce himself much better. So yeah, Karthikeyan, over to you.
Thank you, Prakash. You did an awesome job. Thank you so much. Um, should I start the screen share or?
Sure, go ahead.
Okay, I guess you need to enable me as a co-host or something so that I can screen share.
Yep.
All right.
Yep.
All right. So I'm gonna share the screen and then I'm gonna start the presentation. Just give me 1 sec. Okay. So hi, I'm gonna talk or probably maybe discuss because this is Zoom, so we can make it as much interactive as possible as well. Feel free to drop any questions then and there. So we're gonna discuss about like how to make the open source HashiCorp Vault as highly available tool for the development environment. So that's the topic that we're gonna discuss. The gotcha here is like we're not going to use any new next-gen storage layer. We are going to use NFS as the backend. So I'll be explaining like why NFS is like kind of a hype there in a second. So the first thing I'm going to say is like I'm sure like everyone have encountered or faced or heard about HashiCorp Vault in your journey with cloud native environment, cloud native infrastructure. But so just to give a highlight, like Vault is one of the secret store that you can use for maintaining all your secrets, certificates, any kind of stuff that you want to do hold in your cloud native environment or infrastructure. The problem statement that we're going to solve is like Vault by itself, it's a HashiCorp enterprise product, and the enterprise Vault, the licensed version of the Vault, can form a cluster and can give you high availability, not the open source Vault. So the HashiCorp also provides an open source version of it. It's like kind of a dev environment stuff. That's actually a single container or single binary, which cannot form a cluster by its cluster. You cannot form a cluster or create a cluster with that binary or Docker image. But also the other problem that we're going to see is like NFS are not supportive for Vault because Vault need a leader election policy that should be handled, but NFS doesn't support the leader election policy. So what we're going to do is like we're going to see how we are going to use NFS as the backend, because not everyone or not every firm in the world is like using the next gen storage systems, because NFS is one of the most predominant storage system, which is like kind of relatively cheap to cheap compared to the any other environments. So we're going to use NFS as the backend storage, and we're going to use the open source version of Vault for making it highly available for development environments. So again, a word of advice: this is definitely not for the production environment. We're gonna make this cluster for the development environment, and this is not supported by HashiCorp Vault as well. So this is like kind of a thing like, okay, this is kind of a goofy thing I can do for making a highly available environment for my developers, something like that. It's nearly highly available environment to be precise. So who am I? Like I'm Karthikeyan Govindraj. I go by Karthik, he, him. I'm an open source enthusiast. Like I love open source, honestly, and I write sometimes at Medium about all the open source technologies or like the gotchas or something like how to hack around stuffs like that. I'm a CNCF speaker, and I do Kubernetes contributions in various various repositories on the like KK or K community, and I'm one of the active participant of working group naming, which we recently formed. As I said, like I'm an open source enthusiast. I also want the open source ecosystem to be more inclusive. So I believe in that inclusiveness and part of the inclusive naming, like in the CNCF initiative as well. I work at BlackRock, as Prakash mentioned. BlackRock is not one of the, BlackRock is the biggest asset management system in the world. So we are top. I work as a cloud native developer there, and yeah, that's me. So if you take a closer look at the slide, I have added the QR codes. So I have this habit of adding QR codes after this gone, everything gone virtual. So I've added QR codes for every links and articles whenever there is necessary. So if you have a phone, just grab it and you can do the honors on the. And so now what I'm going to discuss, like what we're going to see in this entire presentation or entire talk is about, like we are going to discuss about what is Vault, how we're going to use Vault. There is another tool called Console. We're going to discuss about that. Kubernetes, of course, it's Kubernetes Bangalore Meetup. A little bit of Golang, a little bit of Helm, and two other utility tools that we have created. So that's the tool list. So now we saw what is Vault, and we saw like what are the problem statements that we're going to cover in this session. So we also, I also wanted to introduce the console. So console is another HashiCorp product. So console is nothing but a key value store. You can use it as a key value store. It's kind of a service mesh basically. You can use it as a key value store. The reason we wanted to use console is console takes using the key value store from console. Console takes care of doing the leader election behind the hoods. So we are going to use console, and on top of that, we're going to use Vault on for using this. So there is a link on the GitHub on the HashiCorp Vault stating like why NFS cannot be used. So on the Vault issues like 4236, you will see like there is a good explanation of like why NFS cannot be used. It's literally the ditto, like NFS doesn't have the leader election policy. It doesn't support the leader election policy. So um, and so again, like what is console? Console is like a DNS based service discovery solution. So you can use not just for key value store. You can use this as a service mesh. You can use this as part of the hybrid cloud service mesh. You can use this as a console. I don't think console has an API gateway, but I guess if it has, you can use it as an integrated health checking tool as well for your services. What we're going to use is like the third one, the distributed key value storage, because we're going to store all the Vault data into console, and then we're going to use the fourth point, the leader election, which is what gonna help us in making our Vault cluster highly available. So for console documentation, you can Google console documentation. I've just added a QR code as well. As I said, I'm just a little bit crazy with the QR codes. So the first thing we're gonna do is like deploy the console into the Kubernetes cluster. How are we gonna do this? So the HashiCorp, the company also provides the official Helm charts for Vault and console as well. So what we're gonna do is like we're gonna use the official Helm chart. We're gonna deploy that on top of any of the Kubernetes cluster. The one thing we're gonna make change is we're gonna point the persistent volume to the NFS storage. So if you have an NFS storage in your with you, like in your company or attached to your Kubernetes cluster per se, that can be provisioned. You can create dynamic, or you can add a static NFS persistent volume, and then attach that NFS persistent volume, maybe like shareable or like maybe individual persistent volume for individual stateful sets. And remember, like we have to put it in stateful sets because for the obvious reasons, it's a state store, and we're going to use that to deploy the console. So again, console uses the Raft protocol, Raft consensus protocol. So when you're using a Raft consensus protocol, it needs to be in a odd number of instances, so that you could the Raft could actually elect a leader, and it would ask the rest of the instances to make them as a follower. So Now if you look at our cluster, we have like the dark pink hexagons or like the console server, and the star one on the rightmost is actually elected as a leader. So those processes, that takes care of itself. We don't need any intervention, like there is no intervention needed from our side to make, okay, you are supposed to be a leader or you are supposed to be a follower, because it uses, as I said, like craft consensus protocol. And then it also deploys the agents in every single worker node. So that's how it is actually discovering the services like any other service mesh. So there is an active, except I guess mesh. So except mesh, every single service mesh deploys its own agents in the nodes. So console does the same thing. All the agents, all the worker nodes will have its agent as a daemon running within that particular worker node, and then the agents will start communicating to the console server. So now what happens is like every single service is deployed on that, every single containers per se, the services deployed on that particular worker nodes are discovered to the console server. And the console server leader will take care of all the writes and shardings and stuffs like that. The followers will take care of the indexing and stuffs like that. So that's this is actually how the cluster will looks after the deployment of the console cluster in the Kubernetes in your Kubernetes cluster. So going through once again, like you have the ingress and you have the console service deployed. So you will be communicating outside from within the cluster using console local service outside of the cluster ingress, and it communicates to the console server, not the worker node, not the agents deployed on the worker node. And the server will take care of the communication or discovery or whatever the key value fetch from the worker nodes. And the bottom box shows rectangle shows that the NFS server has been attached to the cluster as the persistent volume storage for the console. So a quick recap: we have deployed the console cluster with NFS as the backend in our Kubernetes cluster. Nothing more fancy till now. So now what we're gonna do is like we're gonna do deploy the vault into the cluster, into our Kubernetes cluster that we have deployed our console. So again, we're going to use the official Helm chart of Vault, and we're going to say like, okay, I'm going to use, so the official Helm chart of Vault has this, I guess it still has the points to the open source Vault. If it is not, then we're going to say like, use the open source Vault image. And then what we're going to say is like, okay, let me have a 3 replicas of that. Like there is no recommended replicas number in this particular deployment. So I'm just making it up to 3 so that like we have 3 console servers and 3 Vault instances. So the moment we deploy something as it is in the slide, we're going to get 3 independent instances of Vault deployed and running in the same Kubernetes cluster with no communication to the console or anything yet. And it's going to use like in memory until unless we say like use some of the storage layers. So now you have 3 instances of the Vault running there. What we're going to do is like console users, so every single HashiCorp technology, like starting from console, Vault, everything uses its own. They have their own language called HCL, like HashiCorp language. So we're gonna say we're gonna dictate big Vault to you make use of the console as the storage layer. Vault has a native support for console as the backend. It's like kind of fortunate thing. So what we did is like if you look at the highlighted like grayed data in that, like that's a HCL language similar to like kind of a JSON, but a little bit of deviation from that. Like it says like storage and the name is console, and what we say is like, okay, address of the console, we are giving internal service URL because it is deployed within the cluster, assuming it is deployed on the default namespace with the name console. And we are saying like path equal to Vault. So what it says is like in this HCL we are saying like use console as the backend storage, and the location you're going to write is Vault. You can name however you want. There is no restriction on that. There is no recommendation on that. The path is just the location where the Vault is going to write into it. So now after feeding the same configuration to all the 3 instances that are deployed and running independently so far, is going to use the same location, which is nothing but console default as we see. So now what happens is all these 3 instances are sharing the same data under the hood. So say for example, if I'm asking Vault to write, put data like foo equal to bar. So this foo equal to bar is like I'm posting this request to vault instances 1. Now what happens is like this vault instance 1 is actually passing over that data encrypted to this to this console storage. Now console takes care of that and stores it in under the location called vault. So now now I'm asking like, okay, give me the value for foo on the instance number 3, for example, on the vault. Now the third instance of the vault is going to read from the console storage, which is nothing but again the same console default as we see, and it's going to say like, okay, the value of foo equals to bar, and then that's going to give me. So now, though all those 3 instances of the vault are deployed as independent instances or independent services which has no affiliation to any other deployments, they are reading and writing to the same location. So this makes kind of a HA, like a high availability, but not really so sure with that still. The reason is like, I'll explain that in a bit. So here now, all the data sharding, the leader election for writing and reading the data, all these things are taken care by console. So this solves the major problem of having a high availability, to form a cluster with open source vault. So now what we have is like a vault instance deployed with reading and writing taken care by console, which is like kind of nearly highly available. So now that would look something like this. So if you look at the grade hexagons, that's the vault instances that we deployed. So those are the only newest addition there. Nothing else has been added. The previous state was like just the console cluster running successfully. And now we have deployed 3 stateful sets, replicas. That's the vault 0, 1, 0, 2, and 0, 3. Those are communicating to console service and then like writing and reading data through the console server. So now I'm going to explain a little bit about vault initialization process. So vault uses something like a Shamir algorithm. So Adi Shamir was the one who wrote the algorithm. That's a paper on the like bottom right corner on the QR. So it says like you can actually shard a master key to n number, and then you can say like I need at least this m number of maximum threshold to form the master key again. So say for example, I have a secret S, and I can actually shard it from S1 to Sn, and I can say the threshold for bringing back the master key again is 3. So now when I say like the persons on P1, P2, and PK is giving me back 3 keys, which is like unique amongst themselves. Like all those sharded data are like not replicated or not duplicated data. All of them are like individual, and there is no duplication in that. So now forming those 3 keys like S1, S2, and SK will give me back my master key. So why this is important is vault is highly secure, and the one other thing with enterprise vault is like when you use an vault enterprise version, it integrates with the HSM module, like the hardware security module within the hardware. So it actually opts in automatic unsealing and sealing processes. So that's a special function which vault enterprise version. So now vault doesn't allow leakage, as in like when you install or when you deploy vault, the first thing it does is um, sorry, the first thing it's gonna do is like seal it automatically, and it will not be initialized actually. So the first thing we have to do is like initialize the vault and then unseal it. So what does initializing vault means? So initializing vault is like we're gonna say it's just a HTTP call. We're gonna say initialize vault, and we're gonna pass in like, okay, how many? So we're gonna say like pass parameters for the Shamir algorithm. I need like this much number of sharded keys, and I need a threshold of this. And then it's also gonna give you the master key. So that's what the first thing is to first thing we need to do for after deploying the vault. So that's what we're gonna do here. For this particular process, as I said, like we don't want manual intervention in the cloud native infrastructure. So we have the dumbest vault initializer in the world actually. So what it does is it's gonna this particular tool, this sort of tool are already available. Say for example, Kelsey has his own vault initializer. So that's actually specific for GCP. It initializes the vault and stores all the keys and the sharded keys, the root and the sharded keys in the GCP's key store. So same thing, similar to this. So the reason I said the one we have Dumbust is because it just initializes the vault and stores all the key back in the Kubernetes secret. You can change anywhere however you want to store that. And what it does, the cycle of that is nothing but it's just going to so that particular vault initializer has a label selector. The moment this particular initializer is deployed, it's gonna search or it's gonna scan for the available matched pods for that particular labels. So once those are matched, we're gonna look for the vault instances that we deployed. Once that is matched, we're gonna do the HTTP status check. Remember, like all those three instances are independent to each other. Nothing is actually uh, communicating with each other. So it's going to check for the HTTP status, at least one amongst them, and it's going to start communicating to that to initialize the vault. The super cool thing with this is like, since all of those three vault instances are actually using the same storage backend, you're going to initialize only once, and then you can use the same master key and the sharded key for all the rest of the two instances. So the cycle is again like it's going to start, it's going to select the matching pods, it's going to see if the pods are running, say for example vault 01. If the pod is not running, it's going to like go for the next one, and then it's going to go for the cycle within all the array of selected pods. And then if at least one pod is available, it's going to check whether it is initialized. If it is initialized, it's going to just sleep. If it is not initialized, it's going to initialize it and store the value in the secrets, Kubernetes secrets. That's a bad thing. I wouldn't recommend to store back the same secrets in the Kubernetes world, but that's what I'm doing for the sake of the initialization. And the next thing it's going to do is like it's going to actually check for the rest of the pods, and then it's going to see like whether it is sealed or unsealed. If it is unsealed, then it's going to pass in this sharded keys, like 3 if it is the threshold is set as 3, and then it's going to like unseal the rest of the pods as well. So again, it doesn't you don't need to store these value in secrets per se, but this is what I'm doing. And so other thing is like you might ask like why you need to deploy this vault initializer separately. The reason is like we don't want the manual intervention first thing, and this also needs to be deployed alongside the vault pod so that it would communicate within the label selection logics. So now we have initialized, we have unsealed, and the pods are running, and the vault is deployed on top of console cluster, which makes it like a virtual cluster by itself. So are we having the HA highly available vault yet? No. So that's where the problem is. So now I'm going to talk a little bit about Kubernetes and its services. So so the services here is like literally the Kubernetes services, like the one we use to communicate. So when you're deploying something in Kubernetes, like Kubernetes has its probes. So these probes are used to check the readiness, liveness, and the startup of any containers that are running. So like say for example, readiness is like literally used to check whether the container is available, ready to accept the traffic. And the liveness are periodically checked to check whether the container is still running, or if there is any rogue process that is actually eating a lot of memory and making the processes to not respond to any of the requests or something like that. So similar to this, we must need to check the vault statuses as well. The reason is like in the previous slide we saw vault automatically seals, and you need to unseal it. This happens anytime when the vault instances has been restarted. So for example, in your world, if your priority, if your QoS is not guaranteed, not guaranteed, say best effort, your container will be evicted and deployed in some other worker machine. So which means like you're killing a container and your vault service is getting restarted again. So in this case, like until and unless our vault initializer is like scanning that and then passing the master keys to unseal it, that will be closed for request. It will not communicate back with any of your requests. Say if you're going to ask, give me what is the value of foo, it's going to say like error unauthorized, or it's going to say like it is not unsealed yet. So that's the reason like we need that vault, and using a simple bash script would suffice. Like say for example, you can use a post lifecycle hook, or a simple readiness check, and you can kind of make a bash script to kind of a hacky way to do the unsealing thing, but that would spoil your readiness check, readiness and liveness probes behavior. So that's the reason like we are using vault initializer in the first case. And now we have another problem. So we have three instances. Per se, for example, one of your instances is like a kind of evicted and deployed in a new worker node. Now, until and unless the third container is up and running, you should not route your traffic to that particular pod. So what we're gonna do is like you can use your vault readiness and liveness health check probes, but what it's gonna say is like even though if the vault are sealed, it's gonna give you like a 200 status with a message saying like it is sealed. So you cannot really believe on that and use the internal Kubernetes services. So what we have done is like we kind of created another tool utility using Golang. It's one of the dumbest load balancer again. It's similar to the Kubernetes load balancer service. So what it's gonna do is like it's gonna again use the match label selector logic, grab all the vault pods, and then it's going to periodically check. It's going to grab all the pods in an array in a slice, and then it's going to check are all these pods available, like serviceable. Means like are all these vault instances initialized and unsealed and ready for utilization. So if it is not, if it feels like, if it gets a response that okay, this particular pod is still in the sealed state and cannot service any request, it's gonna stop passing the request to that pod, and it's gonna bypass that, and then it's gonna give to the rest of the available pods. So it's one of the simplest load balancer you can see in the Kubernetes world, and it is specifically using the match label selector policy here. And again, this is not deployed on the cluster level. This is again deployed on the alongside with the rest of the vault pods class and the utilities. So this stores the IP address, round robin method. Again, same thing like the preliminary basic routing logics. So now deploying those both vault balancer and the vault initializer utilities, this is how your cluster is going to look. So we have the console cluster deployed up and running successfully there. After that, we have deployed 3 independent instances of the stateful set for Vault, which is using HashiCorp's open source image. And we have provided, we have injected the storage, we have given the storage as console service. So now Vault is using console and it is like still sealed. So we deployed Vault initializer side and alongside pod, which scans and picks up all the Vault instances there. And then it's gonna initialize it, unseal it, and store the keys in the Kubernetes secret. And again, if it is getting restarted, the cycle begins again. It kind of keeps on, like I guess I've set it for like 2 minutes or something like that. The cycle happens, and then it's gonna scan it, and then if it is sealed, it's gonna give the unseal key again. So Vault initializer will takes care of initializing the new instances and unsealing the restarted instances. When I say restarted, as in like killed and continue created newly in a different worker node. So Vault initializer will takes care of the initialization and unsealing aspect of the Vault. So now the Vault, so how are we going to communicate with the Vault? So there are the natural ways like using a load balancer, Kubernetes load balancer, or cluster service, cluster AP service, and then having an ingress on top of that. But what we don't want to do is like we do not want to route the traffic to the pods that are sealed and not ready yet. So we have this Vault balancer which is deployed as an orange hexagon on the top right, bottom right corner on the last worker node. So the Vault balancer is what we're going to expose within the cluster and outside of the cluster. So this Vault load balancer service is nothing but again the Kubernetes service. So that's going to route the traffic to this particular pod, and that pod will make sure the traffics are routed only to the serviceable Kubernetes serviceable Vault instances that are deployed. And we're going to use the same VLB proxy Vault ingress there. So that's how we kind of achieved a nearly highly available environment. And if you ask me, like, maybe before that I can go once again a quick recap of what we have done. So we deployed the console cluster using the console's Helm chart, official Helm chart. Again, so the console, one thing I forgot to mention is like the console cluster that we deployed is actually the open source version of it, and that is capable enough of forming a cluster by itself. So we deployed the 3 instances to make the Raft protocol to elect a leader by itself and having a 2 follower, and the agents are deployed on all the worker nodes attached to a NFS storage under the hood. I mean backend as a backend. So now the console cluster with NFS backend is running successfully. And then we deployed the Vault using the HashiCorp's official chart, pointing to the Vault's open source image and saying like 3 stateful set replicas. So now these 3 stateful set replicas are independent instances until and unless we provide the storage as console. So again, Vault has a native support for console as the storage backend. After that, Vault started using the NFS backend, sorry, console, and via console, we are utilizing NFS as a storage here. Now, Vault is sealed, not initialized and sealed. So we created a utility called Vault initializer, which actually initializes, gets the keys, stores it in the secret, and then pass the keys to unseal the instances. And this happens in cycle to check whether all the containers are in unsealed state. So this takes Vault initializer will takes care of that. Now we have a problem of once the container getting kicked out and restarted in a different node, we have a problem of unavailability, like downtime for like a couple of seconds, probably a minute based on the cluster. We don't want to route traffic to that because using an Kubernetes native services, it would just route the traffic, even though the readiness and liveness probes are there, because the readiness and liveness probes will be resulting as 200 OK status. The reason is like Vault in an uninitialized, in a sealed state still responds to 100 OK and says it is sealed. We created a simple utility called Vault Balancer, and we made sure the Vault Balancer queries on the health and validates whether it is serviceable, which means like in turn it is initialized and it is unsealed, and then it routes the traffic to the corresponding pods. Now we are exposing not the Vault services, we are exposing a service on top of the load balance that we deployed, the utility deployed, and then we are proxying using that from outside of the cluster. So with this, we have created a nearly highly available environment with open source Vault for dev environment. I wouldn't recommend this. This is highly not recommended for production environment. This is only for the dev environment, and this is kind of a hacky way to achieve it. And again, so I've written an article like a while back about this, and this entire presentation is based on top of that as well. In the Medium, like it's there. And again, this is Karthikeyan Govindraj. I go by Karthikeyan. Feel free to ask any questions. And that's about my presentation.
Yes. Just give me a second.
Oh, I see a question from Vijaya. The question is like, any reason to have a custom load balancer when the load balancing be done using the load balancer construct and leverage liveness properties alongside for health check? Yes, Vijaya. So the reason is like the Kubernetes native load balancers would actually just check for the liveness and readiness probes that you are defining, and it is not capable enough to do a custom check. Say for example, so what we want is like to have a readiness and liveness checked against a custom status called is initialized. So what we did is like in our custom load balancer, we are actually doing that by hitting that particular endpoint. And we are saying like, is this unsealed? Is this initialized? And then we are actually including that in our structure, in our struct to route the traffic. And if you are using the native readiness and liveness probes, what happens is like still your liveness and readiness probes are going to give back a 200 OK status on the HTTP call, and then the JSON. So the response is JSON from the Vault instances, and then the response would say like 200 OK, and the status is in sealed state. So which is like not really usable for responding to any of the requests for the Vault, and that's the reason like it's, you can dig into the code. It's very like a dumbest load balancer. It just like picks the request, scans the pod, and then looks for the available pods, and then route the traffic there. Thank you. There is a question from Dinesh saying, what is the maximum number of nodes that Kubernetes can manage? So this is purely a Kubernetes question. I'm going to say like initially when the Kubernetes started, it was 100 nodes. Now there is a blog post from, I guess it was GCP. They have shown like 10,000 nodes per cluster in GCP in GKE. So I guess I can say like 10,000 nodes, worker nodes in Kubernetes cluster. Kubernetes can manage. So Google Kubernetes engine is one of the maximum managed. Sorry, GKE has the maximum managed worker nodes so far, I guess. So it's 10,000.
I think we have 5 more minutes. So in case you have questions, anyone has questions, you can ask right now. In case you want to unmute yourself and ask the question as well, that's fine too.
Dinesh, for your information, like Naboran has also pointed out, there is a limit in the Kubernetes upstream, and the link has been, I mean, the page has been linked to you in the chat.
Yeah, thanks for the details. Yeah.
Thank you.
Hey Karthikeyan, this is Nabaran here. It was a great presentation. I have a few questions,
Sure.
precisely two. Number one, I saw that you used a console cluster. Can we achieve the same HA characteristics using maybe a object storage backend like GCS?
So there are only a certain list of supported backend storage for Vault. I'll probably link the page for that. If GCS object storage is supported by Vault, then yes, of course, you can achieve that as well. Achieve using GCS storage as well.
Okay.
So there are like quite a number of backend supported storages for Vault.
Yeah, so we actually tried once doing with Postgres. It worked really well, but it was not designed to be HA, like
Right.
small consideration. Also, the second question was like, I saw the Vault balancer code. So like instead of having Vault balancer, we can also do it using exec probes, right? So you can just write a curl and a JQ to check for the is initialized status.
Yeah. So I don't really want to deal with a lot of bash scripts per se. And I like really Golang a lot. So yes, you can do that. And if you ask me, this would be more neat than doing that hack. So this is again a hack. So this hack is more clean than doing the bash script hacking. So that's what I mentioned. Like you can do it, but this is more clean.
Yeah. So a bit different opinion. Like exec probes were actually designed for such use cases, like where so a lot of software actually put HTTP status okay even when they are not ready.
Yeah.
But then in the JSON payload they do mention that they're not ready. But yes, yeah. Thanks for answering that.
Thank you. It was a good question. I was trying to get away from that question.
Yeah. No worries. We can anyways discuss that later in the open house.
Sure. So there is a question from Danny. Maybe dumb question. No question is dumb question per se. What would happen if Vault init pod gets killed or that node gets crashed? Definitely, you will not get a HA. So you might need to create multiple Vault initializers as well. But the Vault initializer, the code that I have written, is not aware of multiple instances. So you might want to reconsider writing instance aware code and then create a couple of 3-4 replicas of the Vault initializer as well. And yeah, that's why it's nearly HA. That's a good catch. Thank you, Danny.
Yes. So if there are no further questions, I think we can definitely move forward. And if there are any more questions, I think definitely, Karthik, can you take it at the end of the session as well?
Sure. I'll. And feel free to drop your questions on Twitter. I'm active on Twitter as well, on Slack as well, GK@HJKS. Thank you.
Yes, thank you so much, Karthik. Again, it's always nice to listen to talks where someone brings in something cool that they've done, or some cool hack that worked for them, or something that helps people, the rest of the folks in general as well. So it was great listening to your talk. So I see Sunil has joined us as well. So I'll just go ahead and introduce Sunil. So our next speaker is Sunil Govindan. So he is working as an engineering manager at Cloudera in Bangalore. So he majorly contributes to Kubernetes and Yarn, and he's part of the Unicorn team, which is focusing on running big data workloads on Kubernetes. So today he will be talking to us about efficient Spark scheduling on Kubernetes with Apache Unicorn. So Sunil, are you around?
Yeah. Hey, thanks, Raj.
Yes.
Can you hear me?
Over to you, Sunil. Yes.
Thank you. Thanks a lot. Yeah, thanks for inviting me for this talk. It's really great to talk to you folks here. So good evening. So my name is Sunil. But today in this session, I'll be talking about efficient Spark scheduling on Kubernetes, basically by using a new project, which is Apache Unicorn. It's a Kubernetes scheduler. So I think I'll deep dive into that in the last part of the talk. So let me just share, present it. Please let me know if you can see the screen. Hello. Are you able to see my screen?
Yes, we can see this screen.
Cool. So my name is Sunil. So I work at Cloudera, and I was pretty much an open source guy from 2012 or something like that. And I was working in Apache Hadoop back then into Yarn resource scheduler. So I worked on a bunch of cool features there. And recently, from the last 1.5 years, I started working on Apache Unicorn. It's an incubating project at this point of time, and it's basically concentrating on the scheduling aspects of big data workloads on Kubernetes. So you can reach me at my Twitter handle or at LinkedIn here. Okay, so let's look at the agenda. I would like to go, I think one of the easiest part here is like why Spark on Kubernetes. So I think I'll touch up briefly around that area, and then I'll go a little bit deep dive into the Kubernetes scheduling layer, where when we try to run Spark and we found certain gaps very specifically, and these gaps are pretty much relevant at this point of time, that which is actually denying the user to get the maximum out of the entire orchestrator, that is Kubernetes. So that is one of the initial reason why we want to start with a specific batch scheduler for Kubernetes, which evolved as a unicorn at this point of time. So I'll just take you to that part, and we'll dive into the unicorn features, and I'll give you some of the updates about the community, what we are doing, and the roadmap ahead of us. Okay, so let me go to the first slide here, right, which is about like the past 10 years. So because I worked in Hadoop Yarn, which is actually the big data ecosystem, right, as you guys, many of you guys may or may not know. So that's where the entire big data was landing, and it was HDFS file system and Hadoop Yarn actually as a resource orchestrator, and all these jobs like MapReduce to start with, then Spark and Flink and almost any of the type of big data workloads were actually running on top of that. So we will say that these were pretty much monolithic clusters, and the majority of the jobs were either batch or ETL. And one of the major problem was, yes, as you know, it's a massive cluster, right? I think in one of the Hadoop Yarn cluster, I remember they have 40,000 nodes, which is currently today also they're running. And I know that they scaled up to close to 100K, that is close to 1 lakh nodes in a federated model. So the amount of effort required to manage such a massive clusters, right, it's very difficult. So that's exactly what is happening from the last 5 to 10 years, and even some part of in today's, and maybe in some part of tomorrow. But I think as we look into the future, I think I just captured few other highlights, like it's all about cloud native, and AI and ML is pretty much in the advanced stages, and a lot of innovations are happening in the serverless Lambda layer at AWS. You guys are seeing that how it's happening there. And I'm just coming to this part last as containerization. Yes, Docker, Containerd, and see, yeah, it's pretty much actually helping the users to run their workloads much efficiently. Okay, so let me come to from there, right? With that context, you can see that like why Kubernetes is literally helping, because when the big data workloads need to run much more efficiently in a cloud native environment model, and where some of them actually feeding the data in a processed manner for AI and ML use cases, right? It is very much having a necessity to have a powerful orchestrator, not about Yarn or Mesos, because the Kubernetes actually is more or less there, which is satisfying almost all this condition, and it's proven as one of the best resource orchestrator to run any type of long-term services, right? So that is one of the core reason why the industry itself, or the companies or the users who are using batch workloads, they actually started to move to Kubernetes. So this is actually is happening very well at this moment. And many of the users, I think I know so far, a lot of customers are already moved to Kubernetes, or trying to move, or evaluating how they can move. So that is where the shape. One of the easiest slide for me, I don't need to talk anything here. It is a de facto standard at this point of time. Better isolation, highly pluggable and extensible model, and very easy to operate through Kubernetes in terms of the YAMLs, right? And you can actually twist and turn in the way that you guys want, right? By using a lot of plugins, like for example, network plugins to start with, or a storage plugins like that. So Kubernetes is a definite go there. So why do I need to choose to run Kubernetes, right? Where Spark can run on top of Yarn or Mesos without any problem, or independently. So why Kubernetes, right? So I just highlighted the 4 points. I think this is the exact reason. We are looking to run Spark in a containerized manner, because that is one of the easiest way you can actually have the resource isolation across users. Okay. And second thing is, many of the clusters may be using one Spark Live version called Spark 3 or Spark 2. And suddenly, I want to run a different version of Spark for some POC or something like that, or some real use cases. Today's ecosystem prevents that. So by putting it in a containerized world, and make sure that the dependencies of that Spark use certain Python version, or certain some other dependent library, it is very easy to have it in a containerized way. So the containerization using Docker or whatnot, right? So all these are helping a lot here, so that different types of Spark workloads can run on the same cluster. So that's exactly what you're looking. And more than that, it gives us a unified infrastructure. Basically, like you can run all this kind of ML workloads in the same cluster, and then this data engineering, which is done in Spark, could feed the data to the ML workloads, right? So that's basically, if you see the Google slide in the past, like the entire ML is nothing but 2 to 3%. The rest 98% is all about data engineering. How you take the data and how you ingest it and how you transform it to something else. And projects like Apache Spark helps a lot in that. So having them all together in the same cluster makes a lot of sense, right? And more than that, I want to get much more finer access controls on this shared cluster, where I can actually run and deploy the workload by looking at the access permissions and securities and everything like that. So without any doubt, I think choosing Spark is actually to run on Kubernetes is a no-brainer, and that's where a lot of the companies already are in the phase. And you can see a lot of blogs and case studies and how they are running Spark on Kubernetes. But interestingly, like as you come here, you can see that the Kubernetes was actually a de facto standard to run long-running service, right? It was never designed to run batch workloads. When I say batch workloads, there's a bit of confusion. I can say I very well know, have seen a lot of big data Spark workloads running 10,000 or 20,000 containers or tasks, which will run only for 30 seconds or 45 seconds or maybe a minute, because each of the tasks is to do a transformation from something to else. So take some part of the file, do the transformation, and just emit it to somewhere else. So think about this kind of a big workload running on Kubernetes cluster, right? So that means you need to have 10,000 plus pods come up more or less in a similar time, and need to process it and shut it down, right? So it is a bit costly, and scheduling this kind of a workload is not that easy. There's a bit of challenge over there as well. So that is what all this part, this slide is about, like the lack of first-class application concept, right? So Kubernetes is pretty famous, right? I think you'll be seeing some of the latest work in the scheduler plugin effort and area, but for it is basically port by port scheduling. Kubernetes takes one port at a time, schedule that. But with the jobs like Spark, right, it needs to start a driver port first, then it will become the brain, and it starts multiple workers together. And sometimes to make any progress, they need to get around 10 or 20 port workers together to make any progress. So it's like gang scheduling model. So there is a lot of nuances out there which are needed for to run this different types of Spark workloads for different use cases, because there is Spark SQL, Spark Batch, and different type of Spark jobs. So and having a first-class application concept is very critical. And also a lot of users will be running Spark jobs in the same cluster, and how to ensure that each of them gets a fine-grained way of fine-grained resources from the cluster so that they can run independently and without impacting others. So a one user going in a 10 node cluster running Spark job, it will work, no doubt about that today. But what I'm talking about is like the scale of a 1,000 node Kubernetes cluster where in your organization 100 plus people, data scientists actually are running different type of Spark workloads across org. So think about in that scale, there are gaps. And there are no proper resource fairness across tenants, actually, anything users, and of course a bit of a gap in terms of the scheduler latency or the performance. So I'll just touch up a bit over there. So if you see here, there are two ways we can run Spark on Kubernetes, and one is basically a native model where you just submit a job with a deployment file, massive file, and the Spark driver here, if you can see, this will be the master brain and a bunch of executors will be running. But another way, or the popular way, is like using an operator. So Google has released a Spark Kubernetes operator itself. So that is one of the most famous one. So that operator itself takes care about a lot of complicated things. Like it will ensure that first schedule request is gone for the driver. Then the driver will ask, okay, I need now 10 more containers. And with that, I think they will raise a new request to the API server. So I just try to put a figure around that, like how can I do that? And it's mostly around CRDs and everything. So this is a stable operating model at this point of time. So a lot of users are actually pretty much using this operator to run the Spark on Kubernetes. Okay, so let me go with some more challenges area. One is on the scheduling part, the ordering and queuing. Then that I already touched up, right? So basically, one job runs and it needs to schedule the first driver pod and the workers pod, maybe together in a gang scheduling manner or a different type of policies. So that's kind of missing there. And how do I say that? Okay, I submitted Spark job 1 and then Spark job 2 comes. Maybe to the job number 2 is of higher priority. I just need to balance these two things. There are some priority concept, but I think when you look at in a much more bigger way, these are showing us a clear gaps. And gang scheduling I already mentioned, and then another one is like the resource fairness across jobs and across queues. So one of the fundamental thing I think in big data workloads, if you guys ever worked in a bigger mesos or young clusters, you can see a lot of queues will be there. That means a different organization in the company will have one queues, and each queue will have certain capacity, and you will be submitting your job to that queue. So it will be in a hierarchical way, much more organized, and easy way to manage the resources. So that is one of the a major challenge actually we have seen as a gap in Kubernetes today, and that's I just wanted to make a note of that. So these challenges are not that easy. Um, and also looking into in the latency side, I think I just give some example here: high latency problem, fair sharing, how to do this queuing, elastic and hierarchical priority management, and how to make that controls much more easier. So these are some of the high level challenges. I will go now to unicorn, because though I just mentioned about this bunch of challenges, and these challenges are actually very critical to run these Spark jobs efficiently in a cluster, right? So when I say efficiency, the term is very critical, because the efficiency is not about actually running the job faster. It's all about when I'm running 100 jobs in a cluster, am I able to utilize the maybe up to 90 or 95% of the resource available, right? So that matters. Otherwise, I'm adding more nodes to the cluster, which is going to cost me a lot of money. Maybe if I'm using an autoscaler in GKE, so additional nodes comes in and I'm not using the resources, it's of no use. And am I getting the resources faster, right? Whenever I ask for 100 containers, I think Kubernetes should be able to give me that fast enough. So efficiency is actually measured in various levels. And by looking at that, at the current state of Kubernetes, when we started last year, we found that is not there, and default scheduler is a little tough to maintain that. And we took a decision that, okay, why not? And it's also proven that the Spark or all these kind of workloads, when they were running in the big data ecosystem like Yarn, it was very efficient, because the Apache Spark itself is actually proven to be run in an industry enterprise ready manner in those clusters. So why not take the best of those scheduler features and then get it into Kubernetes? So that's exactly what we are looking, and that's exactly where we started the project called Unicorn. It's basically a standalone resource scheduler and focusing to get the big data capabilities from Yarn or all those similar frameworks and bring it to Kubernetes. This is a very high level architecture. I'm not sure how you can see because the screen is a bit small. So the top you can see the existing scheduler, and the down, like sorry, the left side down, you can see the default scheduler, how it is, how it sorts, filters, and score the nodes to schedule it. But here on the right side, it's basically hierarchical in nature, and we can easily see that I think this particular hierarchical queues are helping jobs to run much efficiently in this cluster. So yeah, the major difference from default scheduler to Unicorn, if you see, Unicorn actually has a hierarchical queue, and more than that, in each queue I can define different policies like FIFO, fair ordering, and between users how to do that, different access controls, and which user can do what action. So almost everything possible is added back. So those were actually the strength in all these big data projects. So we took those constraints and back and injected to Unicorn. So this is a high-level comparison. First-level application concept, because it's a port-by-port scheduling. Default scheduler doesn't have that. Unicorn added that. Ordering policy, FIFO, fairness, priority, all these things are added now. And a fine-grained resource management, we added a hierarchical queue concept in Unicorn, which actually solves that. And end-to-end resource fairness, because within an application we can support more. And scale and performance. So that's basically the biggest part there. So I will start with a little complicated one. I will not take much time because we are running short of time. So this is how the job was getting submitted to Spark on the left side. API server actually creates a driver pod, and it is submitted to a leaf queue in Unicorn. Then the job is starting now. So API server nothing but bind support to an assigned node. But before then, we have done a bunch of action in the Unicorn bottom layer, like sorting the queues, finding the right queue, sorting the app, getting the request, and selecting a node for that. Then the driver port start running. That means it's bounded at the API server level, which is exactly what being shown here. And then the executors are created. That means the driver was there, so that's a master port. Then it actually creates the support. So the request went to Unicorn, and Unicorn actually found that which nodes it can run and updated back to Kubernetes. Then it started running just like that. So everything got bounded there, and it's just a step level how it is running. And since we have this finite control, when even if the Spark driver is asking, okay, I need at least 5 executors to run a job, that's a gang scheduling model. It is doable because in the previous step I will wait till ensure that I get maybe enough nodes in the cluster to run the job. So a lot of control are there, and which is helping us to do this one. Okay, so as you see in the picture, right? So ordering is very critical. If I'm submitting my job earlier, I want my job to run fast. So let's say user 1. A user 2 comes, he submitted a little late, his job need to be delayed as well. And I have an urgent job, maybe priority helps me there to run it first. And basically, what are the different type of ordering policy? FIFO, fair. I think we touched up a bit on that, so I'll quickly go here. And Kubernetes has a namespace resource quota. So many people ask that actually, since the resource namespace quota is already there, why do we need to do multiple queues, right? So one is hierarchical. We have the Unicorn has a hierarchical queue in nature. So you set some higher level quota at the top level, it just split it to smaller queues or sub-organization in the company, and so that the users of that organization can run much efficiently within that silo. So that is actually one of the things. So and few of the problem that we just mentioned, like we literally found certain issues that in namespace quota when it is getting assigned, it does a little early binding, and sometimes we found that when you do autoscaler, we have some issues with that. So coming to the resource quota management, it's basically we have a capability now to work along with the namespaces. So we somehow can detect, like the Unicorn can detect when a namespace is created with a quota. So we map that to a Unicorn queue and make it hierarchical. So that's another way that we solve the problem, because certain companies already using a lot of namespaces very heavily in Kubernetes. So we can internally map to our queue and make this namespaces more or less in a hierarchical structure. So solving another problem. So there are 5 points I mentioned, and why it is required, right? So just going one by one, like a queue can map one-to-one namespaces. So that means no queue management is needed. and capacity can be elastic from min to max, so better resource sharing, that if a queue is having lesser resources, having more resources, so I can steal from the other queue. So all those concepts are there. And fairness is helping to avoid starvation. And then more or less we have enabled job queuing. So job queuing is very critical, so I think I will not touch up deeply there, but simple as that, when you submit a job, the request will be going to a unicorn and it will be queued there. So many times in certain Spark job, if you're on natively on Kubernetes, the submission will fail and go back as a failure to the client. Then client need to retry. So many of the Spark operator code they are written, they are doing a lot of retry from the client side because Kubernetes rejected it. So such kind of queuing mechanism is added in the Unicorn, which helps a lot of big data workloads where your cluster is only small, but you have a massive job which will be running for 8 to 10 hours in thousands or 10,000s of pods. So many of the requests will be queuing. So we need to ensure that that can be queued very efficiently. Okay, so we just did some testing just to ensure that I have multiple queues and how seamlessly I can actually do that. So it's a little difficult to read, but more or less I can translate as it is more or less going with the graph. That means the amount of fairness they were getting across these queues was similar. So as more number of users started using, more jobs are running, still that fairness across queues were good enough. So that's why there was no major deviation from it. So this is actually another important slide. Like we did a stress testing about 5,000 port scheduling on a 2,000 node or 4,000 node cluster. With the help of Alibaba folks, we have done it, and we did the comparison, and this is where it landed. So red line is actually Unicorn, which is giving me around 134% of benefit on top of the default scheduler. And we did two testing actually. So yeah, 130 to 160% is the performance improvement we are seeing. And this is published actually as part of our evaluation by using Kubernetes. So lastly, I think I want to touch upon the compatibility part. So we do ensure that every Kubernetes features that are supported, like for example, predicates is very critical. Taints and tolerations very much used, and persistent volumes. So all those related features we are compatible with. So there is nothing like, even if you replace your default scheduler with Unicorn, it works just as it is. We have a separate Unicorn UI as well. So in case some of the users want to debug their just Spark job or a similar job running on Kubernetes, they can come here and see the application ID, how the resource usage, why it is pending, and all the related things, so they can operate and debug through our console. So let me tell where we are. Slightly outdated, I think. No, okay. So it is Apache open source, and we are giving almost releases every 3 months. The next release is going to be 0.10, slightly delayed, and these are some of the major features we are trying to do. And community level, just to give you some more update, Lyft, you heard about this, like a competitor to Uber in US, right? So they started using Kubernetes Unicorn in a non-production cluster, and they're running around hundreds of large jobs every day, and they are able to make use of all these functionalities from Unicorn and very effectively, and runs good. At Cloudera, they're using there's a product called Cloudera Data Engineering. It is Spark on Kubernetes, and that is powered by Unicorn today. And it's in that product, what happens is like there are like if you're running without Unicorn, many of these functionalities are not possible, like namely queuing, multiple queue management, and resource fairness, and also gang scheduling. So with the help of Unicorn, they're doing that, and it is running with the cluster autoscaler as well. At Alibaba, actually, they're using in a pre-production environment, and Alibaba will be publishing more blogs in the upcoming days. You can see that like their EMR actually is using, will be using Unicorn, and it's one of the biggest. They will be one of the biggest consumer of Unicorn, and their development team is actually actively working a lot in the community at this point of time. So where we want to go, different type of workloads, right? Batch workloads or Spark or Flink, like streaming workloads. Almost all of them will be able to run in Unicorn. Different types like DB microservices or batch jobs or non long running, any type. I think ideally we'll be able to serve that as well. And we are looking also ensure that multi-tenant use cases and meeting the customer SLA and better resource utilization and also cost management those are the areas that we want to ensure that we tick mark them and finish it so that like the users can enjoy the benefit of all. And this is our community, unicorn.apache.org. You can go there and see the latest work we have done, documentation, how to install, and our GitHub repo and the mailing list and Slack channel. Everything is here. So I think I'll be sharing the site. It will help you. So we do welcome all of you guys to try it out and join our community and collaborate more. And so we'll be able to make this one of a great scheduler for Kubernetes. And with that, thank you. I think I'll open for questions.
Guys, so in case you have any questions, you can either ask it in the chat section or just unmute and ask Sunil directly.
Oh, okay, sorry. Yeah, I think my question is out of topic, but I'm beginner. I wanted to know about the shadow opportunity, which is with each release. I think this is about the Kubernetes releases, I presume. So before every Kubernetes releases, like I think the one was, I think the 20 release, right? So they invite for or an opportunity to join the release team. You can shadow, so that whenever they request that, you can go and apply. And based on your experiences and work that you have done, they will evaluate your candidateship, and if it's fine, they will accept you, and otherwise they'll give you a reason what area that you can do, so that the upcoming release, at least you can shadow them. So I think you need to watch out for that. I don't know. I think it's coming from Kubernetes IO handle. They usually publish it before every releases. Yeah, I think, yeah. Right. Somebody else can add more. It'll be great. Yeah.
Yes, there's one question from Dinesh. He's asking how Unicorn is different from Apache Airflow.
Got it. So Apache Airflow is basically something similar to Uzi, if you know about it. It's both about job scheduler, which can say that, okay, I have a job one. So job one is maybe transforming maybe 1,000,000 record and transform that to maybe 1,000 records and write it in Parquet format. That may be job one. The job two will be about read the Parquet file and do some other transformation. So these may be two different jobs altogether, and different one may be using say for example a Unicorn, one may be using Spark, or they may be using Flink, or maybe using MapReduce itself. That is like a workflow designer to me. So somebody want to define a workflow for their entire data engineering pipeline. That is where they use Apache Airflow, and whatever workflow they define, at the end of the day, it will be submitted as either a Spark job or a Flink job or any type of job, and that job will be running on Kubernetes. And Unicorn is nothing but a scheduler inside the Kubernetes, which will be giving you additional benefit of to run batch workloads much efficiently. So think about Apache Airflow as a workflow which you create at the top level, which submits the jobs into Kubernetes. When the job one finishes, with the help of Unicorn, say, and the response come back to Airflow, they will run the second job after that. So they just pipelines it. So that's basically the difference between Airflow and Unicorn. Is nothing but a scheduler behind the scenes in Kubernetes ecosystem. Hope that clarifies the question. Can Unicorn handle real-time workflow loads? Yes, you are correct. So when I say real-time workflow loads, you may be using, I'll take for Flink actually as an example. So Flink do have streaming, and Spark also have streaming. So all this kind of real-time workflow, when it comes, yes, at the end of the day, you will be submitting to Kubernetes as a deployment file, right? So it will be nothing but a deployment or like a job. And that request, when it lands, what we do is, like, we have an admission controller running in the Kubernetes ecosystem. So whenever any type of job comes, it actually adds scheduler name to the deployment and make it as Unicorn. So when API server sees that, it actually gives that request to Unicorn to schedule, and we will call the bind API at some time later to bind that node to that request. So basically, it's all about what kind of workloads will be running on Kubernetes, and our admission controller, which is running on the Kubernetes cluster, will help to inject the Unicorn scheduler name and other few parameters that will take care of doing the scheduling later. But yeah, we are running, actually, I know there are customers who are running Flink on Kubernetes with the help of Unicorn. So there are a few customer use cases in the Apache open source. So in the open source community, they are using it already.
Okay, so if there are no more questions, so I think this brings us to the end of the session. Thank you so much, Sunil. Definitely we learned a lot about the project from you. So the speakers are still around. So in case any of you still have questions, you can just hit them up. We also have tweeted their Twitter IDs, right? So you can get in touch with them outside the session as well on Twitter to know more about the topics they talked about. So I would like to begin the vote of thanks right now. I would like to thank everyone who joined us today. Thank you to the speakers. Thank you to the attendees. Thank you all for joining us today for the meetup. Also, please do not start leaving yet. We have a few more things to discuss with you, so it would help a lot if you stay. So also one more thing I would want to mention is that almost all of us here are on the Kubernetes Slack. I think the link is slack.k8s.io. Nabaran or Suraj, if you can post that link. So you will find most of us over there. So in case you want to keep in touch or ask questions to the community and interact with the Kubernetes community itself, especially the Kubernetes community from India. We have 3 India-specific channels: in-dev, in-events, and in-users. So yeah, we have 3 India-specific channels as well with people from India in those channels. So you can find all of us there. So you can interact with us there. One more thing that I forgot to, but we need to definitely thank is I would like to thank Kinfolk for sponsoring the Zoom for this session. Without their support, this Zoom session wouldn't have been possible. Earlier, we used to do it on StreamYard to YouTube streaming. So this time we are trying something different. If this works, I think we will continue doing Zoom sessions in the future. Also, we are on Twitter. Our Twitter ID is K8SBLR. So you can follow us on Twitter. We post the new meetup announcements. And we tweet a lot about Kubernetes, and we engage with our audience a lot on Twitter. So you can follow us on Twitter as well. And if you want to submit a talk, or if you want to talk about something, you can get in touch with us on Twitter, on Meetup, or on Slack, the Kubernetes Slack, and you can present your talks in one of the upcoming meetups as well. And also, if you like what we're doing, and if you think that someone has a use, can look at these videos and learn from it, or it would help someone, you can go ahead. This session was live on YouTube as well. So we will be tweeting out the YouTube link soon. So you can share it with someone who you think it might help as well. So that brings us to the end. Suraj, are you there? Would you like to add something?
No, not really. You go ahead.
Yes. So I think we can stop the